Notice that in the last example, we will have a solution x1, x2, x3 in 3 variables. Now, if we were to graph the feasible region, the solution to the maximizing objective function would appear at a corner point, but graphing in 3D is really difficult, and if we added another vegetable, x4, it would be impossible to graph. So the simplex method will find the corner points that maximizes the function using matrix methods, which don't require sketching a graph at all. Thank goodness. Also note that there are 5 variables, x1, x2, x3, s1, and s2, but only 2 equations. So because there are more variables than equations, there's going to be an infinite amount of solutions, but only some are feasible and only one's going to maximize it. So to get a unique non-negative feasible solution which corresponds to a corner point, we're going to set 3 of the variables equal to 0 and then solve for the other 2. So if 3 of the 5 are equal to 0, then the other 2 are going to get you a unique solution because we only have 2 equations. So 2 equations are going to let you have 2 non-zero solutions. So we're going to start on the corner point 0, 0, 0. So we're going to let x1 equal 0, x2 equal 0, and x3 equal 0, and then just solve for the other 2 variables, s1 and s2. So if we set x1 equal to 0, and x2 equal to 0, and x3 equal to 0, when I try to rewrite the first equation is going to say 1 times x1, but my x1 is 0, right? So 1 times 0, well, that's just 0. There's no point in actually even writing it. Plus 1 times x2, but x2 is 0, remember? So that's 0 as well. Plus 1 times x3, but x3 is also 0. So it's as if these columns, x1, x2, x3, because they're equal to 0, when I multiply the coefficients times 0, it's as if they don't exist. So when I rewrite the first equation here, this is going to get me s1 plus 0s2 plus 0z, so I'm not going to write those, equals 100. The next equation, so for x1 I have 10 times 0, which is 0, 4 times 0, which is 0, 7 times 0, which is 0, 0 s1s, so I'm not going to write that. I have 1 s2 plus 0 z's, so I'm not going to write that, equals 500. And for the last one, the maximizing objective function, I have negative 120 times 0, negative 40 times 0, negative 60 times 0, plus 0 s1s plus 0 s2s plus 1z equals 0. So the solution x1 equals 0, x2 equals 0, x3 equals 0, s1 equaling 100, s2 equaling 500 is hardly optimal. It gives a 0 profit for our objective function, z, but did you notice how easy it was to solve for s1 and s2? These are because s1 and s2 are called basic variables for this problem. So let's define what a basic variable is. A basic variable is a variable that only has one non-zero coefficient within the constraints and objective functions. So to find the basic variables in a simplex tableau, find a column that only has one non-zero number. The variable associated with this is called the basic variable. So if I go back up to our problem here, notice that S1, in the column S1, I only have one non-zero number. That's our 1. All of the other values in our simplex tableau are equal to 0. S2. S2 is also a basic because up and down we have only one non-zero number. That's the 1 in the second row. All of the other values are 0. If we try to look in another column, let's say x1, do you notice how there is 3 non-zero values, 1, 10, and negative 120? So this is not a basic variable. What if we look in the next column? Nope, those have 1, 4, and negative 40. There's not only one non-zero, there's 3 non-zeros. And the last one as well, 1, 7, negative 60. That doesn't work because we have 3 non-zero values. Only in the pink column and the yellow column do we have only one non-zero number. And that is what makes that variable basic. So for our next problem, I am going to give you a simplex tableau, and I want you to read the solution from it. So step 1, identify all the basic variables. Looking up and down, x1, I have 2, 10, and negative 120. That's not basic. x2, though, is basic, and the reason this is basic is because there's only one non-zero number. So 0, 6, and 0. 6 is the only non-zero number, so that means that column is a basic variable column. x3, 4, 7, and negative 16. Nope, that's not basic. s1, 5, 11, and 0. Nope, that's not basic. Even though it has a 0, all of the other variables have to be 0 except 1. How about s2? s2 is also basic because we only have one non-zero number and the other two are 0. Now z can never be a basic variable because z is the thing that we're maximizing. So we're just talking about our variables x1, x2, x3, s1, and s2. We're not talking about z, even though that really does look like a basic variable. Z is not a variable. It's a maximizing objective, so we don't consider that. So what are my basic variables? My basic variables are x2 and s2. That means my non-basic variables are all of the rest of them. x1, x3, and s1. Okay. So what we're going to do is we're going to let all of the non-basic variables be 0. So x1 is going to be 0, x3 is going to be 0, s1 is going to be 0. So if you just put like a line through it, and then I read my equation left to right, I'm going to have 2 constraints and 1 objective function. So if I'm reading the first equation, we have 0x2, so I'm not going to write it. We have 2s2 plus 0z equals 31. All right, our next second row, I have 6x2 plus no s2 plus no z's equals 360. And then our last objective function, we have 0x2 plus 0s2. We have 4z equals 84. So now I can solve for s2 and x2. So that divides by 2, and my s2 equals 31 over 2. How about the next equation? I have divided by 6, and that gets me x2 equals 60, and then my objective function I can solve for z, and I get z equals 21. So in summary, my solution, x1 was non-basic, so I set that equal to 0. x2 turned out to be 60. x3 was a bit non-basic, so it's 0. The slack variables, s1 is non-basic, so it was 0, set to 0. s2 turned out to be 31 over 2. And then our optimization was 21. So our objective function is going to be 21 for this particular solution. I'm not sure if this is going to be the best solution or not, because we haven't learned that quite yet, but this is how you read a solution from a corner point off a simplex tableau.